Hi folks, welcome to my channel, The Average Dermadoc. Let's begin the show.
Dermal Epidermal Junction. It is nothing but a complex form of basement membrane. First we will see what are basement membranes. They underlie epithelial cells and endothelial cells. Some forms of basement membrane also surrounds nerve cells and smooth muscle cells. Such basement membranes are called external lamina because they are surrounding the exterior of smooth muscle cells, nerve cells. This word lamina we are going to listen multiple times while dealing with DEJ. Coming to functions of basement membranes are diverse. Diverse means different. They will perform different functions based on their location. We will see one by one. First, acting as a substrate for attachment of cells, that is nothing but epithelial cells and endothelial cells. For them, this basement membrane will act as a substrate for their attachment. It also fixes their polarity. That means the side of the cell which is attached to basement membrane will form basal end, and the end which is exactly opposite to it and free will form apical end. Like this, basement membrane fixes the polarity of either epithelial cell or endothelial cell. Next, it stabilizes the tissue orientation. In embryogenesis, the organ's orientation will be decided by basement membranes also. Hence, if the basement membrane is defective, organogenesis will also be defective. It provides a template for repair after injury, not only formation of organs but also repair after their injury. For example, if we have ruptured a superficial most pimple, the basement membrane will be intact and fine without damage. So it will act as a template for the repair of the damaged superficial most skin, and it will regain its function without any defect. For suppose if we have ruptured a big sized pimple which is deep enough to rupture basement membrane also, then that part of skin will lose its function because of scarring. That's why it is very important to not to rupture any pimple and control ourselves, which is very difficult, but we have to restrain from rupturing any pimple to avoid scar formation. If once a scar is formed, that structure will no longer will perform its function properly. We all must have heard that if lung gets fibrosed, that part of the lung will be permanently losing its function. And in case of tumors, if basement membrane is intact, then the tumor cells spread will be prevented by basement membrane and it will contain the tumor. We can excise and remove that cancer. For suppose once the basement membrane is broken or ruptured, these cancer cells will gain access to spread to different parts of the body. That is nothing but metastasis. See how important an intact basement membrane is. Next, it acts as a barrier, physical barrier, separating the epithelium from underlying extracellular matrix. It will also act as selective permeability barrier. For example, in kidneys, like glomerular basement membrane, if this basement membrane is defective, it will no longer perform its natural selective permeability function, like removing the toxins from blood and excreting via urine. It will lead to hematuria, proteinuria, affecting the kidneys. One such example of structural defect in glomerular basement membrane is Alport's syndrome. What is the exact structure which is defective in Alport's syndrome? Next, permeability basement membrane is outside the brain, blood-brain barrier. This is nothing but a basement membrane which prevents the entry of toxins circulating in the blood to reach the brain and affect it. Once this basement membrane is defective or got damaged, then the toxins in the blood will gain access to the brain and damages the brain. Next, strong adhesive property. The main function of dermal epidermal junction is strong adhesive property, fixing or attaching epidermis to dermis. and also regulates cellular functions, all the functions of the cell like growth, division, differentiation, and ultimately death like apoptosis also is regulated by basement membrane only. I'll give you the best example. What is the epithelium of skin? It is nothing but stratified, which means it has multiple layers. Squamous epithelium. It is given the name because the topmost layer contains squamous cells. Now, the basal most cells of the skin epithelium is attached to our basement membrane. These cells will get growth factors and signals to divide from basement membrane. These cells are having stem cell property because they are dividing cells. One cell will divide into two daughter cells. One daughter cell will regain its attachment with basement membrane. Another daughter cell will detach from basement membrane and gets a signal. At the point where it gets detaches, it will get a signal from basement membrane to start differentiation. Then it will differentiate to stratum spinosum, then to stratum granulosum, then ultimately to stratum corneum. At this point where it reaches stratum corneum, it will have lost all its organelles including nuclei, and it will be died at the level of stratum corneum, and it will ultimately shed off from the epithelium of skin, that is stratified squamous epithelium. There is nothing but epidermis. This entire process is called keratinization, which is nothing but a specialized form of apoptosis. As it is happening in a keratinocyte, it is called keratinization. The exact starting point is getting detached from the basement membrane. So after listening this story, the exact inner feeling of any basement membrane towards its epithelial cell will be like this. Until and unless you are attached to me, you will be alive. I will be providing you growth factors and signals to grow. Whenever you get detached from me, you are going to die ultimately. Coming to our topic proper, dermo-epidermal junction. It is a highly complex form of basement membrane acting as an interface. Interface means junction. Here it is the junction between epidermis and dermis. That's why it is called dermo-epidermal junction. It is divided into three zones. Because it is having multiple zones, we can also call it as basement membrane zone. Specific name for our basement membrane in between epidermis and dermis. Dermis contains extracellular matrix. Epidermis is nothing but epithelium. Justifying this point, separation between epithelium and underlying extracellular matrix. What are the three zones? Zone 1, keratin intermediate filaments, which is nothing but tonofilaments, and hemidesmosome complex within the basal keratinocyte. Actually, these two structures will lie within the basal cell, but it will also contribute to the functioning of the basement membrane and attachment of epidermis to lamina lucida. That's why we have included it in zone 1. Even it is not structurally a part of the basement membrane. All these components of basement membrane are attaching complexes or anchoring proteins or scaffolding proteins which anchors to another structure. That another structure will go on anchoring to some other structure, ultimately fulfilling the aim of attaching or adhesing epidermis towards dermis. You can see here all the double-edged arrow marks are indicating that anchoring, continuous network of anchoring with one structure to another structure. Here keratin intermediate filaments to inner dense plaque of hemidesmosomes, inner dense plaque to outer dense plaque of hemidesmosomes. Inner dense plaque contains two structures, plectin and BPAG1. One is for first structure, inner dense plaque. Next to BPAG2, outer dense plaque. We are going from outside to inside, epidermis towards dermis. Outer dense plaque contain integrins, which is nothing but alpha 6 beta 4 integrin. Here This arrow mark is extending from outer dense plaque to into lamina lucida. We can see two arrow marks representing two structures. As outer dense plaque of hemidesmosome is a transmembrane structure, which means it will cross the plasma membrane of basal keratinocyte. Think this as a basal keratinocyte plasma membrane. You can see two arrow marks crossing the plasma membrane, representing the transmembrane nature of the proteins. From outer dense plaque entering to lamina lucida, two structures. One is BPAG2, nothing but collagen 17. Another one is alpha 6 beta 4 integrin. These two from outer dense plaque of hemidesmosome entering to lamina lucida to get its attachment to next structure. Here you can see alpha 6 beta 4 is attaching to the next structure, that is anchoring filament, laminin 332. This blue box is representing lamina lucida containing three structures. Nothing but structures coming from above and one structure coming from below. From above, two structures, collagen 17 BPH2, alpha 6 beta 4 integrin. Both these structures not completely inside the lamina lucida, only the ectodomain parts. Where are the endodomain parts? In outer dense plaque. So clear, ectodomains will be lying in lamina lucida. Like this, one more structure coming from below, anchoring filament, attaching to alpha 6 beta 4 integrin, anchoring tightly to connect ultimately epidermis to dermis. Next, zone 2. Simple. From here it is simple. Lamina densa is zone 2 containing collagen 4 mainly. That's why I have highlighted with star mark. Next, stabilizing structures like nidogen, perlecan, fibulin. Final zone, sublamina densa, which contains mainly anchoring fibrils, that is collagen 7, which goes and anchors to lamina densa, and interstitial collagen of papillary dermis. We have reached dermis, forming a contiguous network of anchoring structures attaching epidermis to dermis. By now, we have finished the structures of dermo-epidermal junction completely. From now onwards, I will be revising in theory, written form, and then I will draw a diagram and will revise again. Whatever I am teaching now, just imagine yourself while finally drawing, we will revise. Molecular components of basement membrane zone are attachment structures that form a contiguous network extending from basal keratinocytes towards upper papillary dermis. We can see here from basal keratinocyte, keratin intermediate filament, hemidesmosomes to papillary dermis. It is forming a contiguous network. Here you can see contiguous network until papillary dermis from basal cell of epidermis, ultimately connecting epidermis and dermis. We will see one by one all the components. Just imagine and keep it in your brain. Coming to individual components of the basement membrane. From zone 1, which contains keratin intermediate filaments, which forms cytoskeletal network inside keratinocytes. Just like our human body has bones as a skeleton, cells also contain keratin intermediate filament as its skeletal network. So it is called cytoskeletal network. In basal layer of the epidermis, these keratin intermediate filaments are keratin 5-14, which anchors desmosomes to inner dense plaque of hemidesmosomes. In stratum spinosum, these keratin intermediate filaments will be differentiated from keratin 5-14 to keratin 1 and 10. So only in basal cell, this keratin intermediate filaments anchors desmosomes with hemidesmosomes. Hemidesmosomes in turn goes and connects to basement membrane, ultimately connecting the basal layer of epidermis and dermo-epidermal junction. Then you should get a doubt how the rest of the layers of the skin are connected with each other via desmosomes. Ultimately, in basal layer, desmosomes will go and connect to hemidesmosomes via keratin intermediate filaments. This will lead to indirect connection of rest of the layers of the epidermis also with that of the basement membrane. If there is a structural defect in this keratin 514 within basal cell, it will lead to epidermolysis bullosa simplex. Most common form of epidermolysis bullosa diseases is simplex. S for simplex, S for superficial defect. If superficial most structures of basement membranes like keratin intermediate filament which goes and attaches to our inner dense block of hemidesmosomes. What inner dense block contains? Plectin and 1 BPAG1. So all these three structures are superficial most structures which leads to epidermolysis bullosa simplex. There are three types of structural defect diseases. First one, epidermolysis bullosa simplex. Next, junctional epidermolysis bullosa. Next, dystrophic epidermolysis bullosa. First one finished, epidermolysis bullosa simplex, because of three structural defects. First three structures. One we have finished now, keratin 514. Next two we will come to know now. Next structure, hemidesmosomes. These are electron dense attachment complexes on basal plasma membrane of basal cells, which mediates the adhesion of basal keratinocytes to basement membrane zone. How? By extending from intracellular compartment of basal cells into the lamina lucida. Already I have told you how they will extend via transmembrane proteins like BPAG2 and alpha 6 beta 4 integrin. That's the work of hemidesmosome, connecting the basal cell with the basement membrane by extending transmembrane components and by connecting to keratin intermediate filament above. It has two domains, inner dense block, outer dense block. We know what inner dense block connects. Above, keratin intermediate filaments. Below, obviously, outer dense block. Next, outer dense block has transmembrane structures. We already seen BPAG2, alpha 6 beta 4 integrin, which extends into lamina lucida, and then there it connects with next below structures. We have already seen plectin and BPAG1 are inner dense block which if gets structural defects, it will lead to epidermolysis bullosa simplex. If you go in depth, plectin defect causes epidermolysis bullosa simplex with muscular atrophy, epidermolysis bullosa simplex with pyloric atresia. To remember this, I have highlighted the alphabet A, which represents the first alphabet. First most structures like plectin, keratin 5-4 and BPAG1. 1 means first most structure. First defect, epidermolysis bullosa simplex. Next, second defect, epidermolysis bullosa junctionalis. Next, second three structures like alpha 6 beta 4 integrin, BPAG2, laminin 332 leads to junctional epidermolysis bullosa. Whatever the structures present in lamina lucida, if they gets defect, it leads to junctional epidermolysis bullosa. See here, what are the structures present in lamina lucida? Alpha 6 beta 4 integrin. You can see it is causing junctional epidermolysis bullosa primarily. Then BPAG2, ectodomains of these two structures. BPAG2 is also causing junctional epidermolysis bullosa. Next, laminin 332. It is also causing junctional epidermolysis bullosa and also laryngo-onychocutaneous syndrome. L for laminin 332, L for laryngo-onychocutaneous syndrome. No need to remember this. This is only for toppers who wants to diagnose rare cases. Alpha 6 beta 4 has two parts. One is A for alpha, A for first alphabet. So first defect epidermolysis bullosa simplex. Next B for beta, second alphabet. Second defect junctional epidermolysis bullosa. Like this, remember alpha 6 beta 4 causes both epidermolysis bullosa simplex, S for simplex, S for superficial, first superficial most structures. Next, second defect junctional epidermolysis bullosa because of defects in whatever the structures present in lamina lucida, all three structures, alpha 6 beta 4 integrin, BPAG2 ectodomains, laminin 332, junctional epidermolysis bullosa. Only the last defect is left out, that is dystrophic epidermolysis bullosa. We will see which defect causes it. Next structure, lamina densa. We all know its main component is collagen 4. Collagen 4 is a ubiquitous component of dermoepidermal junction. Ubiquitous component of basement membrane. Ubiquitous means it is omnipresent. It is present in almost all types of basement membranes, not only dermoepidermal junction. If it gets defective in its structure, it leads to Alport syndrome. That's why basement membrane of kidneys are getting affected primarily in Alport syndrome. It is also known as basal lamina. Lamina densa is also known as basal lamina. It contains stabilizing structures like nidogen, perlecan and fibulin. Here I have wrote laminin 5. It is nothing but laminin 332 only. Here it is entering lamina densa also and contributing to lamina densa. Next, sublamina densa, also known as lamina fibroreticularis. Its main component is collagen 7. We have seen collagen 7 goes and binds to, anchors to above structure lamina densa, and below it anchors to elastic fibers and interstitial collagen of papillary dermis, connecting lamina densa with papillary dermis ultimately. If collagen 7 gets structural defect, it leads to dystrophic epidermolysis bullosa. Third defect, last and final most defect, dystrophic epidermolysis bullosa. Which defect causes which disease you should have in your fingertips. When you get a question on the disease, first you have to write what is the main cause of the disease from here, from basic question. Now we will revise 3 defects. First most defect, epidermolysis bullosa simplex. S for simplex, S for superficial most structures. What are those? Keratin 5, 14, plectin, BPAG 1. Next, junctional epidermolysis bullosa. Second structural defect, second most structures. Beta 4, B for second alphabet, second defect, junctional epidermolysis bullosa. Alpha 6, beta 4, integrin, and all the structures in lamina lucida. Laminin 332, BPAG 2. Here 2 for second numerical, second defect, junctional epidermolysis bullosa. Here also 2 for second defect, second structural defect, junctional epidermolysis bullosa. Third and last deepest structure, collagen 7 in sublamina densa, below lamina densa, leading to dystrophic epidermolysis bullosa. Those are all structural defects because of genetic defects. That's why they are called as blistering genodermatosis. What if our own body produces antibodies against components of dermoepidermal junction? It will lead to autoimmune bullous diseases. Example, if antibodies are formed mainly against BPAG2 and also on BPAG1, it will lead to Bullous pemphigoid, name itself telling BPAG, and also linear IgA disease, mucous membrane pemphigoid, if they are formed against laminin 332. anchoring filament. It will lead to epidermolysis bullosa acquisita, linear IgA disease, and mucous membrane pemphigoid. If autoantibodies are formed against collagen 7, it will lead to epidermolysis bullosa acquisita. When I am writing my final theory exam, I got this question, epidermolysis bullosa acquisita. Remember like this, AF anchoring either anchoring fibril, either anchoring filament. If our body forms antibodies against them, it will lead to epidermolysis bullosa acquisita. Collagen 4, if antibodies are formed against collagen 4, it will lead to Goodpasture syndrome affecting lungs and kidneys. Not related to us. BPAG1, name itself telling, bullous pemphigoid. AF anchoring fibril, anchoring filament, whatever. If antibodies are formed against them, it will lead to epidermolysis bullosa acquisita. Now, whatever we have imagined, while knowing about each and every component, we will write here. First defect, what is that? Epidermolysis bullosa simplex. Because of superficial most structure defects, what are those? Keratin 5, 14. These are the keratins present in basal layer of keratinocyte inside this basal cell. First, you imagine like entering a epidermis layer by layer. You have entered stratum corneum. What you will see? You will see flat dead cells without nucleus. Then enter granulosum. You can see lot of keratohyalin granules. Then enter stratum spinosum. You can see keratin 1, 10 intermediate filaments. Next, enter basal layer, which will be connected with dermoepidermal junction via keratin 5, 14. It is present only in basal cells. Keratin 5, keratin 14. It will anchor desmosomes and hemidesmosomes. Here, desmosomes are connecting adjacent keratinocytes, ultimately connecting all the keratinocytes indirectly with basal layer with dermoepidermal junction. Now we will see next structure, that is hemidesmosomes. It is divided into inner dense plaque and outer dense plaque. Inner dense plaque connects with outer dense plaque. This is plectin. This is BPAG1, which weighs 220 kilodaltons. Clear? Inner dense plaque contains BPAG1, plectin, which connects keratin intermediate filaments with outer dense plaque. Outer dense plaque sends it to transmembrane structures into the lamina lucida. What are those two structures? One is BPAG2. Already one finished in inner dense plaque, BPAG2. Another one is alpha 6 beta 4 integrin. These two enters lamina lucida. For easy remembrance, I will draw it as 6 for alpha 6, B for beta 4. This is alpha 6 beta 4 entering from outer dense plaque to inside the lamina lucida. Lamina lucida is a electrolucent layer. Just it will have all the structures passing through it. Next, we have finished lamina lucida. Next, lamina densa. From lamina densa, one more structure entering into lucida is anchoring filaments. There is nothing but laminin 3, 3, 2, also known as laminin 5. So, total 3 structures in lamina lucida came. What are those? BPAG2, alpha 6 beta 4 integrin, laminin 332. If these structures got structural defect, what will it lead to? Junctional epidermolysis bullosa. Rest of the above structures, what are those? Keratin 514, plectin, BPAG1. If these three are having structural defect, it will lead to Epidermolysis bullosa, simplex. S for simplex, S for superficial, most 3 structures. Keratin 514, BPAG1 and plectin. Here all the structures present in lamina lucida. Next, lamina densa. It contains collagen 4, nidogen, perlecan and this laminin 332 anchoring filament. Finish. Next, deepest, last and final layer, sublamina densa. What it will contain? Anchoring fibrils. These are curved collagenous proteins which goes and connects above structure lamina densa, below interstitial collagen of papillary dermis. That's it. We came until papillary dermis with a contiguous network of attachment structures. Here you may feel very messy, but in this diagram you will see very clearly. You can label and practice on your own. Now for your ease, I will label and show what are these structures. Here we will label just zones. What is mainly in zone 1? Keratin 514, hemidesmosome, lamina lucida. Next zone, lamina densa, and then finally sublamina densa. Finish. Here we will write individual components. Keratin 514, plectin. You can see in inner dense block 2 structures, plectin and BPAG1, which in turn connecting to outer dense block. This 6 for alpha 6 is beta for beta 4 integrin. This is BPAG2. This is laminin 332. Double edged arrow marks are laminin 332, also known as laminin 5, which connects one side alpha 6 beta 4, another side lamina densa structures. Then at the end, last and final deepest layer, sublamina densa, containing anchoring fibrils, that is nothing but curved collagenous protein, collagen 7, which is connecting to interstitial collagen of papillary dermis. Here you can see collagen 4, laminin 332, nidogen and perlecan. This is inner dense block. This is outer dense block, which sends 2 structures, BPAG2, alpha 6, beta 4 integrin into lamina lucida. Remember my channel name TADD. Don't forget to like, share and subscribe. Thank you. Hasta la vista. Das vidania.